Right. Welcome to Research Jam number 22. We have four speakers today. Gonna have a lot of time. We can allow questions during and after. And as usual, the has a wide coverage. It's pretty fun. And that's my dog. Hey, let's get started. We're gonna start with Chris Lee.
My name is Chris Lee, and today I was going to present in the I have an idea category for generative CAD. The question is, if you were to redesign CAD today, what would it look like? Gotten some presentations, questions asking if this is Canadian dollars. No, CAD is computer-aided design. And it's a fun question to see where it came from. I had done a little research. Basically, people have said close to the 1950s, it all got started. CAD generally allows for the creation of electronic symbols, geometric figures, circuit diagrams, flowcharts, anything that a draftsperson would be doing. And to kind of put this in a time frame, in 1957, that's when Sputnik was launched. And this is a pretty cool demo of this person named Ivan Sutherland. I didn't know about him, but you can see him drawing three lines on a screen, 1963, almost 61 years ago. And then I turned off the audio, but the interviewer's mind is blown. How is this being done? You have the XY coordinates, preceded obviously the iPad. But Ivan Sutherland's a pretty cool guy. He was an autodidactic, couldn't read until late age, went to Carnegie Mellon, MIT. This is his PhD thesis that you're watching. And he later started the computer graphics department at Harvard and started the computer science department at Caltech. And all his work, his son has pointed him to be like the grandfather of GUIs as well. And he's won like the Turing Award for this effort. So it's kind of cool. Another timestamp, what happened in 1963. That's when Julia Child, a celebrity chef, went to France and made the show and popularized that. And it was also when MLK had a I Have a Dream speech. So it was quite a bit of a time ago. 1967 is when MIT really coined the CAD terminology. It was called AED for a long time. Douglas Ross is another person. And it's been a decade of efforts. And it's a pretty fun reference in terms of a lot of people asking about how MIT has approached design on the computer. 1967, Vietnam War protests, Cultural Revolution in China. So it's kind of interesting to see this development happen in the US and amidst global events. So now that we know a little bit of the history of CAD, I thought a lot about why is this domain interesting. There's many ways to cut the pie. Generally, the top three categories are number one, architecture, engineering, construction. Number two, product design, manufacturing. And third, they're trying to get into like some games and media entertainment. And there's a lot of ways from 2D to 3D to modeling, whether it's turbine engines to games and media. And there's all these software suites. And you can kind of go down the column and think about, is this data in the internet? Is there training data for me to get? Is there a lot of references or documentations for a BMW gear versus things in the open? And how many collaborators are there? Is it narrowly scoped? Can you do zero-shot prompting with existing models? But today I'm going to just focus on the 2D era before going too much. There's a few startups and efforts in the other areas. And this is a fun paper that it was presented at CBPR a few years ago, kind of popular within Google Scholar, 300 or so references, but more, everyone kind of knows it within the architecture space. Big firms that have developed the World Trade Center or the National Mall are trying to do this internally. And when I say do this, they basically create it's a GAN model on a 60,000 floor plan drawing, and it was done by researchers at Simon Fraser University in Vancouver and Autodesk. But the method is pretty straightforward. GAN's Ian Goodfellow, but they take a 60,000 house layout and they just define the edge relationships, which encodes the functional connection of an interior door or a front door as it would be represented in a real architect sketch in Figure 2. And then in Figure 4, basically it's a graph constrained relational GAN. And they condition that on the previously generated model that becomes the next input constraint, which allows them to do iterative layout refinement, which is an important point because typically you get the end drawing of a architect's plan, not every single step. And the ground truth on figure 4 segmentation is passed and is a component in this condition at a random probability they set at 50%. And at least their research has argued that their discovery has argued that this approach is just as good as a previous house scan approach in which they didn't use the iterative generator. So the results very quickly in the blue shows building plans that look pretty close to ground truth as they define it. And they got 10 architects and 10 specialists to all rate all these things. And everything to the left, you'll see, looks a little bit odd. And the two on the left tried using integer programming, so basically strict AI, and the one Johnson used just simple optimization. And it's a fun thing because a little bit unintuitive of what they've done is that typically when you're an architect, you build the core first, meaning the living room, and then you go outwards and you build the doors and windows last. But they found that their method, doing the doors first, was actually the most helpful. So it's like almost reversed. But I think what's interesting to know is that it's a pretty small project in 2021. It's straightforward, I think, for this group in this audience. But one workstation, I think that's 1/10 of an H100. It's a small data set, actually released by a Chinese company and university students. But the key takeaways, I think, is that the paper addressed the lack of databases containing step-by-step design iterations. And second, I think they had questions around what ground truth looks like. It was relatively subjective. And the reason why I think this is really interesting to share and why it's relevant is that within AEC, or architecture, engineering, construction, I'm going to take a side quest and giving you a quick contextual knowledge of why this is so exciting in this industry. This on the right is a quick video of what a normal architect does. And I'm sure everyone's thinking, oh, a digital agent should be doing this, but visually you're looking up codes. Like, this is what an architect does on a day-to-day basis. Whether you're modifying a driveway and you get that instructions by text or email, and you're manually moving these numbers around, which is a very painful process. I think most architects come out of architecture school. In architecture school, you're doing 90% design and 10%, debugging. But when you're in the industry, it's almost flipped. Like, you're almost an accountant. And the best way for me that I found to explain the life of construction is through the pseudocode to the left. And there's almost like a generator and discriminator. So given a site address and a prompt, whatever, it's like 49 Van Ness, I want to create a pineapple building. Usually a human being or an agent will look up the address, look at the code and the zoning limits. And within that, you generate a design schematic, they call it. And you might have some constraints from the owner or the architect or the contractor saying, oh, I want to put a bathtub here, or I want to put a hot tub and cold plunge on my roof. And the architect says, well, let me go check the code. But these constraints are oftentimes random, because your contractor might hit groundwater, or you might have some delay, or your partner doesn't want the hot tub on the roof. And you iterate that multiple times. In my personal experience doing this, it's like 20 to 50 times before you have a construction document that you can submit to the city. And when you're submitting the city, you're running the approved project function multiple times. You take the design, D sub 20, and the address, and you have basically an array of architects, engineers, sub-engineers, people that are specialists in mechanical or environmental. And then you have on the city side, the planning department, the inspector, and I call the last bias, but because it's a little bit of a time series of code changes. You might have two inspectors that contradict or disagree with one another, but you more or less map everyone's understanding and have a semblance of ground truth or an agreement with everyone. And you basically go through a loop of saying, does this ground truth from these people match the designs? And does that equal to what the reality of the site address and design is. And if it's not, your inspector will have comments, your contractor will have comments, et cetera, and you basically iterate back to the drawing board multiple times until you get approved. And that's one of the reasons why it's so slow. And this is actually a screenshot from study material for an architect. They have to do 3 years of masters and have multiple board exams. And very quickly, you know, it's very on the left, people produce drawings. It's almost like an IKEA. If you ever built IKEA furniture or bought something on Amazon, it's frustrating when you don't have a good set of design. And creating that is a very manual effort, and it's prone to errors. And to put it in like programming language, there's no documentation, no GitHub, no unit tests, no compilers, very few macros. And it'd be pretty amazing to auto-generate documentation, have instant permitting, and also robotic instant inspection in this world, not just from a small single family home, but even building new Transbay train station. And I think what's cool about this is that simple paper had birthed 2 companies, one in the US and one in China. I'll start with the one on the right. HiArc was the Autodesk people were the managers of the research at Autodesk AI. It's raised $78 million. It looks a little bit like SimCity, but it's a software based on this research with 70 employees. And when I referenced the R-Plan dataset, it actually came from the company on the left. And it was founded by 3 master's students at University of Illinois. They raised $300 million, 1,300 employees, done really, really well. The video is from 8 years ago, so I was able to find an earlier video, but it kind of gives the group an illustration of how one simple paper have kind of birthed, or what the market potential is for pretty much like a strict AI, very small pre-diffusion type of effort. But I think, I think this is fun for me, and I think fun because we all want to bring creativity to the real world. I think everyone who has tried to get housing or start a company or complain about it, like it's all. And, the request for plot is very simple. Based on this one paper, can we do a few things? First, can we use an existing foundation model to be fine-tuned to the problem space here? Second, this discriminator was done against a ground truth determined by just 10 architects, but is there a way to write the Palo Alto building codes into the discriminator? And then second, can we create unit test compilers for these building codes in a way that, well, I can probably do one demo very quickly for a single family home in Palo Alto, but there's a lot of scope from warehouses to multifamily to even fire station code all over the world, from Cape Town to New York. And all of this is online. And again, there's no GitHub for this, but I'm trying to think of a way to aggregate this unstructured data. And lastly, I think I have some strategies and access to very large data sets from very large players. If you weren't constrained on data set or compute, what are some new methods or outcomes? And it's not just CAD in real estate. I think there's also fun adjacent ideas that this group might be curious about, but one that came up in a discussion is generative origami. I think that's always been a fun area. And obviously generative Lego is maybe a simpler idea, but that's what I wanted to discuss with this group today, if people had insights in any of these topics.
Thanks for the presentation. This is pretty interesting. Any questions from the audience? One simple thing I wonder about here is how many buildings that are designed and then built and permitted actually meet building codes versus like are close enough that they get signed off. Should you have some fuzziness in the model?
Yeah, no, it's a really good question. From personal experience, it's kind of a crapshoot. When I've done my interviews with a number of architects and civil engineers, the thing they mention often is that this isn't rocket science. The accuracy of the drawings themselves are closer to 70%, and that's great enough, which is kind of shocking in many ways. And again, I've had situations where you have 2 different fire inspectors that will contradict each other because these building codes aren't like they're put another way, just that no one deletes, they just add. So, a culmination of a lot of conflicts and logics, and you can call it bureaucracy of different interests. And I'm gonna get a little philosophical, but when I talk to developers, they're basically people who are risk-seeking people looking for a reward. And what's a landlord? A landlord is a risk-averse person. So you have like diametrically opposite interests in what I see, laissez-faire, invisible hand, everyone acting in their own self-interest market. So that's why we have all this here in the West in many ways. But whereas in Asia, there's more in Europe, there's more cooperation, or in Asia, there might be a master plan. But it would be, in my mind, pretty amazing for anyone in this group to say, hey, I'm gonna, whatever I imagine, like Minecraft, I can make it into reality, just like how Airbnb and Uber have changed the ability for people to do new things. So to not get rid of these traits of architecture, but just to unleash the amount of creativity that people have instead of moving these schematic designs that I showed in that video earlier. But yeah, that's kind of what we want to do.
So you have two steps here. You propose fine tune and compile. I wonder if it would end up being just one step, because recent LLMs you see, they learn better from pairs of like the design that meet the code, design that don't meet the code, and just have enough of the samples, and the compiler, so-called, or discriminator is trained that way. So I wonder whether the fine-tune part where you want the model to understand the documents is really needed.
That's a really good point. We've thrown a few of these documents at multiple programs and had them try to create, and I think their post-training scripting or filters are too strict. It's potential that they're able to do this and that they don't want to share everything. So you might be right, that it might be just like one step. And what's a little fuzzy for me is that if I pull up single family home regulations in Palo Alto,
Voila.
I need to interpreting the visual length of whether or not this building is too close to what's called a setback against the adjacent neighbor's land. I'm sure there's some open source method of interpreting a CAD file, which is just a string of numbers anyways, I'm assuming, to show that there is some type of relationship with the border. So like things like that is a little bit murky to me, but I can only assume it's been done by someone interpreting a CAD file. And it might not be Sonnet or ChatGPT. It might be something. That's great.
One thing I wonder here is whether or not it's possible to kind of iterate back and forth with the model, but also a human designer. So one thing GANs are good at is that you ask it, give me 20 options, and it gives you 20 options. And then you can easily say, you pick the one you like. At some point in the process, I imagine, if this is being used by an architect or an architect with homeowners to be sitting next to them, they're generating 20 designs, they're picking one. At some point, they take that design and say, we like this, let's start with this. They kind of like export it into a completely different format where they can now edit it in their normal CAD software. They move some walls around. And then what they really want to do is after they move some walls around, they want to say, now let's see different bedroom layouts, right? So you kind of want to take the edits they make, put it back into the model, regenerate, and you have this like two-way flow of information being possible. Whereas with many GANs, this is not possible directly out of the box. I guess in your investigation here, Chris, did you see that as an option or as something that was considered?
Yeah, I think there was one working paper where they are trying to adjust this ground truth. And I think it's small enough that theoretically in today's robust MacBook Pro, you might be able to run this, you should be able to run this locally, which should be neat. And maybe it's just getting the best ground, to your point, pointing towards the best ground truth designs that we know are, again, 10 feet away from the setbacks that the model begins to learn. But I think we're going to poke around. That's a really good suggestion in terms of, and I mean, the question also too is that I don't even know if it's on GANs, or I don't think anyone is really using GANs these days, is that it's a great starting point to kind of learn what is feasible. But moving to diffusion might be better, but it's a good starting point for sure.
Any other
question, Chris? I've done some 3D scanning and CAD designed over the
Mhm.
years. They're very professional. What's your accuracy requirement here? How did you have to be 100% accurate, or what's the goal?
In terms of the design matching the construction or the
But for example, I think billing code, I would assume
Oh.
that higher requirement and the design matching the actual thing. I think it has to be some sort of aligned to, but I'm not sure. Because when it comes to CAD or actual implementations of hardware, there's always some
Yeah.
error tolerance that you
Yeah.
have to that in. My friends, I have a few friends who are like always getting board exams. So I'm trying to pass those things. So
Yeah.
it's
So
really hard. So I'm just curious what you think.
there's different constraints. From what I understand, I think on the structural engineering part, it's pretty close to 99.9. Because there's shear loads and vertical loads, especially as you get more complex, where that becomes extremely it needs to be very accurate. And then and that's why in the defense of the planning department, they have to defend against unscrupulous developers, and that's why the contractor, the architect, the structural engineers all have to provide the stamp. But it's close. It truly is like close to 70% accurate. My own experience, you can like open walls. You might find like a coffee cup from like 30 years ago in the wall. And a lot of people, when we talk to like people who do infrastructure development, so there's a friend who's doing the train in Washington from Bellevue to Redmond, and even though it's like a few thousands of people, they're competing against another firm, and even though you have a freedom of request for the information, they'll send you the drawings, but you have to go out and make the what's called as-built. You have to go out and make all the measurements all over again, because a lot of times you might theoretically want to create, you know, a highway, but it might be off by a few inches. So roughly, I think in the industrial biolabs commercial sense, I think within 1%. And then in the residential, because anyone here can pull a permit from the city and just install a solar roof or knock down a bedroom door and like do your own construction. So it really is given to anyone to control. And in that arena, it's a lot less accurate.
Yeah. I'm asking is only because that if the accuracy, I work in the healthcare domain, so the cost of one negative or like false prediction is really high. But I assume for your domain is probably more attainable.
Yeah, in this domain, it's not the accuracy that is the issue, it's the time. And the time is the biggest drag towards like capital return, or if you ever done your own. So the idea of like instant permitting or instant generation is extremely valuable.
Yes.
And it's incredible that you're sending this drawing in and it's like prone to human understanding of building code, human perception, and human error across 12 different departments, from mechanical to environmental to plumbing, electrical, et cetera, et cetera. And when I say compiler, like there's no, it's all logic. So it should all get approved. So this can get dragged on from like 4 months to sometimes 48 months. And that's, I think, been a lot of, even for a very simple standard design like an ADU or a prefabbed accessory dwelling unit, where they've approved many of these before. But because it's a new person, because it's a new arrangement, even the very big companies still need 6 to 8 months to like get it all set and done. So because there's a human in the loop, it's good that you can collect these comments and these adjustments, but it's bad in the sense that, you know, I was talking to this very large developer yesterday and just making the comments like, you know, how much has car manufacturing changed besides robotic arms? It's like, this is even less in the construction industry. So it's a little bit frustrating, but I think, you know, there's opportunity because, again, anyone who goes into prop tech we all come from the same base of like, hey, we just want to get affordable, or we want to have housing, like, and how do we solve this? So yeah.
Very cool. Yeah. Right now, I think with inflation, a lot of people are thinking about prefab homes. Those are, and then I think the permits that is terrible, and yes, at least in Boston. So we don't see a lot of them, but very cool project.
In the interest of time, we should probably wrap up. Let's all give Chris a round of applause, though. Nice pineapple. Chris, if you want to, or anyone else, if you want to, there's the Research Jam channel on Discord. People are welcome to kind of continue the conversation there after this call.
I think someone in chat was just saying, They have interest, so I'm sharing your website.
Thank
Okay.
you.
And we can move on to Tianqi.
First of all, thank you so much for joining. I know a lot of you woke up really early. Very luckily, I am in Boston and it's my lunchtime. By way of introduction, my name is Tian. I am a data scientist working for a health insurance company for the last 5 years. So all I do is I look at medical and pharmacy claims. What it is I see how much hospitals and doctors charge, how much insurance covers, and how much patients has to pay to afford or to get a necessary medical treatments or medical care. One thing I can't get my head around over the past years is that why is medical care so expensive? The US Congress was thinking about the same thing. In 2021, they passed a bill called Medical Pricing Transparency Act. The gist of it is that if they make pricing transparent, maybe people can shop around, and that's a way of reducing the medical cost. The thing is, what they require a hospital to do is on the right-hand side here. Hospitals just need to disclose their pricing in a machine-readable format. Rosie, I see your screen, you're trying to see this, that this is machine-readable format, so most people don't know how to analyze it unless you're a data scientist or you're AI scientist who can really read it in your Python notebook or other machine-readable formats. So that's why the problem is still there. Early this year, Kaiser Foundation did a survey that said 75% of US adults worry about being able to afford unexpected medical bills. That's the majority of the population, and that is the level of that's the level of problem that we're looking at here. Interestingly, medical bills are full of errors, unfortunately. A lot of people, when they get their medical bills, they wonder things like, oh, did I request that extra exam? Was that test necessary? Why is this extra procedure added to my bill? So that when you look at the total, it's a huge bill. A lot of people cannot afford medical bills, so a lot of them call their doctors to negotiate questions like this, especially for patients who are enrolled in high deductible insurance plans. 50% of American workforce right nowadays enroll in high deductible plans just because they either can't afford their high monthly premiums, or that they just don't want to spend that much every month. And when there's an accident happens, they are screwed. The good news is that if you dispute your medical bills, it's likely that you will get your medical bill reduced. I'll give you a statistic number, around 60 to 70% of them usually are able to reduce their medical bills, either eliminating some procedures or just to reduce that scope to something that's affordable. What we're trying to do here is to simplify that process until the hospital system can adopt technology like this so that they can resolve errors on their end without pushing all the errors on the patients and then have them dispute all the time. And this is where my co-presenter, Tianqi, comes into play. I'm very fortunate to have him. He was a software engineer at PayPal. He worked on the FAQ documents. He contributes to the search bars on the PayPal website. So he has a lot of experience in the NLP domain. He's been teaching himself a lot about generative AI. And that's where I also come in to learn alongside with him. What we're trying to do is to create an LM model or application that takes in one person's medical bill. We then can compare that against the pricing that hospital disclosed or other regulations or protections that this patient entitles to, and or find out other similar precedents so that we can hold this patient's hand through this painful journey of getting a medical bill reduced. So exactly what we're trying to do is a medical bill negotiation instruction with some references. I make some quick mock-up just to share what the idea is. So the first step is you describe your medical bill situation, or you just upload your medical bill. And then we confirm all the information that we need in order to give you some tips that you can act on, like hospital names, what's your insurance, and any other free text concerns. Then boom, we tell you something that, for example, the first bullet point is that we spot some errors on your medical bills. The charges on your bill is different from the charges that the hospital disclosed on the website. And we'll give you a link so that when you talk to the hospital, you can say that, hey, in your own words, you say this procedure is only $100, but you charge me $500, for example, to get that medical bill reduced with reasonable arguments. The second thing is, if your insurance sucks, you don't have to use your insurance. You can also negotiate to pay cash with your hospitals, and many times that is way less than through your. And then in this specific in this specific person's case, this person is eligible for financial assistance. And we can also help these patients learn how to apply for financial assistance with their own with this specific hospital. If none of these goes anywhere, we can also direct this person to some websites where you can file complaints to ask the federal government or state government to intervene and help you with your journey on getting this medical bill into a reasonable price range for you to pay. So that's where we are in terms of like the discovery and our idea. We've started to do some research to understand the limit and the boundary of existing foundational models. One thing we notice is that these foundational models don't perform that well when it comes to regulations and protections that patients are entitled to, because A, all these things changes very fast, and B, these things varies based on where the procedure was conducted, where the patient resides, and when did this thing happen. So I'm starting to collect, I have access to a large data set on regulations like this. I'm also starting to collect my own proprietary data sets to fine tune this model. So this are the discovery. For the next few 10-ish minutes, we would love to ask feedback on two things. One is evaluation metrics. Well, how do we know that we succeed? What are our North Stars? What I'm doing right now is to recruit users, and Tianchi is going to talk more about how he's thinking to build this model or using prompting to achieve this. If you have any thoughts on the technical side of things or any thoughts on the product design, we would love to hear them. The other thing is, how else would you solve this problem? Right now, we're thinking about using the LM approach. A lot of it, I definitely don't want to overkill. If we could use prompting, we use prompting. But ultimately, I also hope that this can be something that we can publish. So if you think of ways that opportunities where we can fine tune in our presentations, we'll love to appreciate you pointing that out to us. And there are other technical things that we try to keep in mind. One is how to avoid catastrophic forgetting. We're training a big model, so we're still figuring out ways to avoid that. And then we also always ask ourselves, are we using the right tech stack architectures? If you know of any resources, anyone to talk to, any papers or models, data sets we should refer to, we would love to learn that from you as well. Now, I would love to pass the microphone to Tianchi for the second half of the presentation.
One question. In what format are you ingesting the bills? Is it an image or copy-paste text? Or
Great questions. Right now, we don't have the OCR capability built out, so you have to type in free form. But in the future, you can just upload it can be a screenshot, and it can be a medical bills. A little context here, hospitals takes forever to give you the bill, but insurance companies send you bill relatively faster through their apps. So what I do is I just download a screenshot, and the thinking is to be able to ingest both screenshots and the medical bills. Yeah.
So we are building our own knowledge base, and we try to merge our knowledge base with the LLM model, and we are meeting some. We have some question about override existing knowledge, inject the new knowledge, and the proper way to measure it. First one is that in some scenario we need to override the existing knowledge, and maybe it's just a small part of it. Take this example. The customer might want to know how to be eligible for the extra help program, and the program, the model right now is answering pretty well. It's just that a small regulation is changed. The threshold of income is changed. So we just need to change that number. Then, well, we will be good for this answer. So a few possible solutions we have is that first we can have a reg to retrieve the proper information and put it as a context into the model, and we do have a good result of that. The concern we have with reg right now is that given the complexity of the medical health problem, we might end up need to build a lot of retrieve system, retrieve different information, and this will increase the token that we put into the model. And this model right now are priced based on tokens, so the bill will be huge. So another way we are thinking about is that maybe we can try to use fine-tune to kind of override this knowledge. So one way I'm thinking about is that I will just have the original question and answering pair layer, and I only change the knowledge that I want to override, then I start a fine-tune process. But I'm not sure if this will work. And even though it works, whether this slight change will have some unexpected result. Maybe yeah, for this prompt, it is changed. But for another related prompt, it might not change. How do we detect this kind of situation, and how do we detect the catastrophic forgetting? So that's a problem that we are thinking right now for override existing knowledge. Can you move to the next slide? The other scenario is pretty similar, is inject the new knowledge. So maybe there will be a new fact concept. For example, Texas previously has a hurricane bureau, and there were a few new regulations supporting the victims of this hurricane. So we want to inject this kind of knowledge to our LLM model. So one thing we think about is that maybe you can fine tune it. We create a pair, we rephrase the questions and pair with the same answer to, and hopefully that after training, the model can answer the result. But another dilemma here. So in the classic machine learning problem, maybe we want to have more training data to train the model, and hopefully it can be generalized well. But there's also a new theory that this is more for alignment, meaning that for each knowledge, I only use one training sample for it instead of a lot of it. And for some research paper claim that fewer training sample is actually can improve the performance of the model. So that's another question. We would love to have discussion with you guys. And that's for the knowledge injection. And moving to the evaluation and the seventh slide. The final question we have is about the evaluation, how to properly evaluate whether the knowledge is updated or injected. And I think most of the paper we are reading right now, they are used a quantitative way. For each knowledge, maybe I can design different questions, and we ask people to read those questions and read the answer from machine to check whether machine is answer correctly. Then we collect the data to have some quantitative metric. I believe that is a very good way to go, but we wonder whether there are more effective and simple way to evaluate the result. So that's our thoughts in mind, and we will be very appreciative if there is a better idea or suggestion or on the research papers.
Thanks, Tianqi.
Really cool idea, you guys. The technical details aside, it really seems like if you just put this up online, people could start using it really quickly. I think a nice thing is you might have a few hundred users initially, but each of your users might be very, very motivated to use the website, use the software, because they care a lot about the results. And so they might be willing to do a lot of back and forth interaction with your chatbot, which honestly might be in the whole process the most friendly thing they talk to, right? They're probably people like stuck in the middle of a problem that they really, really, really hate.
Yeah.
And a site, a chatbot that's like trying to help them might be really well received.
Thanks, Jason. Yeah, I've been thinking about that as well, trying to find a forum to launch this in beta. I haven't figured out a way. I think I found some forums, but yeah, we're still building anyways. We have this thing. I can probably show it real quick. It's just that right now it's for the pricing transparency, right? I just show you that black box. I turn that black box into a search box here. So you can type in your hospital names, what procedure did you do, and what was the price, and then we can help you figure out if there's any discrepancy. So that's what's done right now. I haven't really figured out whether it is ready to be shared with. Good.
That's cool. In the process of users talking to, I guess, the hospital, do they have to mail things in, or can they email, or how do they communicate back and forth with the hospital?
Yeah, that sucks. You have to call them, and then until you bother them enough that they probably will be willing to receive your emails. So yeah, unfortunately.
That's hard because it's hard to standardize. With the literal talking, I guess.
But like when it comes to like filings official complaints against the hospital, that is something we can formalize. After our reasonable attempts to contact the hospitals, there's no resolution recourse, we can involve agencies to help.
So just curious, the number they showed, like 70% of the cases do get their bills reduced. Did you analyze the reason? Was there like some error just introducing the bills? One scan was listed to 2 scans, or what was the reduction?
So a lot of the hospitals, once you give them reasonable request, they will give you like 20% discount or something. So like they might not be willing to acknowledge their error of like, this is an example here, there are duplications. They might not be willing to acknowledge that they made a mistake or whatsoever, but they're willing to reduce the size of the bill. I see a lot of self-reported data on that.
On the technical side, just my impression is that your problem, the knowledge editing, updating, is pretty well handled by in-context learning these days. People often think that fine-tuning is an overkill. Things might change, of course, going forward. But at this point in time, I think like prompting, which means you gather all the new information, put it in a context, call it RAG or whatever, is still the best way to go.
We have some internal experience right now, and right now the in-context use RAG or some local retrieval method. It is pretty promising.
Yeah.
And but we just want to explore some other way. Yeah.
Well, definitely we should keep an eye out on the fine-tuning techniques, but so far, I don't know, all those efficient fine-tuning techniques seems promising, but most of them still destroys the model or makes the model forget things. We talked about how RAG might retrieve way too many information and making it costly. I realize whenever you need to look up a document for something relevant, it's only like one or two paragraphs that are really relevant. The others are just part of the document. So maybe if you have a good filtering mechanism or knowing where to look and only extract that part into your LLM, that could be a good way to go.
Yeah, agree. Yeah, I think that would be our next step to build this system.
Cool. Okay, I got to know a totally new domain and didn't know that 70% of the bills can be reduced. It's amazing. I should try call every time, at least bother them to see what happens.
By the way, if you know of anyone who is currently battling their bills, we are 100% willing to help. I'm an expert in this domain from like disputing my own bills and, from my career. I'm really happy to help, and that will help us design our models better as well, collect more information.
Do we have your information listed online? I guess we have your LinkedIn. We have your LinkedIn and this presentation slides. Is there a website you want to point people to or email?
Yeah, so I have my own email here, my personal and Tianqi's email. If you have any questions or follow-up or need any help from us that we can support, please contact us. I think my LinkedIn is linked in the agenda as well, so feel free to contact me on LinkedIn. Thanks so much.
All right, we're at about 20 minutes, so we should probably wrap up. Let's all thank Tianyu and Tianqi for presenting. If you guys are interested, please hop over to Discord and feel free to chat more there if you want.
Next up, we have Ratchet.
Hey, hi. Okay. So thank you so much for letting me present today. And basically, this one is called Rising Model Machines. And basically, I stole this from the concept of model computation. And I've been working on this for 3 years, and apparently it started as a science fiction, but that became a reality. So that's why I'm giving this talk. So before I start, I'm grateful to ML Collective for helping us with the resources. So thank you so much for helping us. And whatever I'm about to say is in peer review, so I can't say much, but I will just show whatever small things we have. And the reason I am giving a talk here is because it's not published yet, so it's not a full paper, but it's not an idea also. And Hinton's Glom is basically working right now, and it's sitting in my desk. So and I am pretty clueless, and there are people who know a lot better than us, and yeah, we will be grateful for any advice on that. So basically, last year I had been screaming in NeurIPS corridors that everything we have been doing is wrong, and neither transformer, nor LLM, nor diffusion, nothing is making sense. And I'll tell you, so this is a problem I call as the stupid scaling up problem. And we'll run through that by a history. So if you look at the first paper Turing wrote, look at the last section of it, that's called a learning machine. And then Frank invented Macaulay-Pitts neuron, and then Minsky trashed perceptrons, and that led to AI winter. Then PDP group in CMU kept on fighting, and then Boltzmann machines worked. Boltzmann machines just stole concepts from Ludwig's Boltzmann, and the goddamn thing never worked, right? And then the learning algorithm looked beautiful though. And then backprop worked, so that was published in Nature. Deep belief nets came, and then Dr. Bengio just kept like, he said that, okay, take the layers and just stack them greedily over one another, train one module over with respect to another, and then finally just pump your inference module at the end. But it took too long because when you're training modules individually, there is no end-to-end training. So then Alex came along and he said that no worries, take a CNN, scale it up and use backprop. And then NVIDIA entered in 2012. And while your brain can work on a sandwich, your GPU still takes 1500 watts per second. So, and if you see, this has been the trend till now. Just keep giving your money to the GPU companies. Who cares about Earth? Mars is around the corner. So that's also fine. And we scale too much now. So let's prune it. So we take a big fat model and we trim some fat. So you train like a 50 billion or 100 billion parameter model, and then you trim the neurons. And you know what? You will quantize its weights too. So convert 64-bit to 8-bit, and we'll call it mobile llama. And also you are a mathematician. You take a weight matrix, model it as an eigenvector, and then trim the coefficients which are not along the diagonals. But the key point is you still have to train like the bigger model. And if you really did your learning better, then you could have able to train a very large model, a very small model, which could work very well than if you trained a big model and then quantized it. But there is something fundamental which is going wrong, which is why it's not working. So I talked to a lot of people and they said that we are the big guy, we can't afford it. And guess what? We'll build a cluster. It's the era of Gen AI. We will order 10,000 hoppers and we have infinite money. And yeah, there is no problem of electricity, right? Because we have infinite fossil fuels. And meanwhile, yeah, people in academia are just struggling. So yeah, we are in the grave right now. So now the other problem is that if you look at your model, if it goes up, if you have a lot of layers, then you will split the layers also. So you say, I will put 50 layers on GPU1 and 50 layers on GPU2, and then I'll train them. And basically what is going to happen is, let's say a rat comes along and he eats the wire connecting your GPU. So it's not going to work. Basically what we are doing now is that, so if you look at the 2019 paper by Cindy, that said that you can basically take a module, you can take a deep learning module and you can split its layers, and each of the layers will communicate only with the input before that. And the learning is local and there is no more global backpropagation. And you still need layers. So this whole 4-decade affair is what is known as the scaling up problem. So now it's not gonna go away because as we see that it's the trend of scaling up. So we need to do something drastic. So this was a paper which was published by Jobser in 2021, which was called GLOM, and it was not working. It was just saying that if it was to be made to work, then it should help us improve a lot of things which we have been doing. And it's trying to combine the advances which were made in transformers, neural fields, and capsules and other things. So this was like the key idea there, that at each pixel you have a vector, and basically so if you have a dog, each pixel of the dog will have a vector, and all the vectors will agree among themselves, and that will tell us that it's a presence of dog in the image. So this is something which was called as islands of agreement, but it has like remained a purely theoretical concept. But we actually found it in a transformer in NeurIPS. So these are the islands of agreement we were able to find in a MWIT V2. So at least like to the best of our knowledge, we have never seen outputs like these. And this is without any semantic labels, without boxes, and without any upsampling and there is no decoder. Basically, what we do is we take a video transformer like MVIT V2, and then we pump an image in it. We repeat the image many times, that becomes a video. And then we are just doing TSNE clustering on the third or fourth layer of the transformer. And then we are just upsampling it by using a interpolate function, which is like non-parametric. So that actually led us to believe that maybe since the representation is already found, we can actually try to do something better with it. So then in GLOM, basically the conclusion of the GLOM is saying that perception is really a field, and whatever model of GLOM we got working. So right now here, what we are showing is that if you look at the Mona Lisa and the other picture, we are able to interpolate between these photographs. And this is not a GAN, and this is not a diffusion model, and there is no alpha matting. This is GLOM. The key idea is that if you take a neural field and you have a 3D neural field, you overfit, then you get view synthesis. But if you make a neural field work for all the 2D images in the world, then you get generative behavior. So in the 3D space, it's interpolation. In 2D space, it's generation, it's perceptual interpolation. So that is what like we were able to get. And then another change we have made is that there is no more parallel perception. So the problem with attention is that it consumes too much memory, and he really gotta go. So fundamentally, the problem is that if you have n, so let's say you have n patches and you want to process them, that is not gonna work because it will take too much memory. The best we can do is look at each patch once, and that will make it order of n. And that's what low rank adaptation and state space does. We are talking O1, we are not talking ON. So the way it works is, let's say you want to process a patch of 224. So if you relied on a transformer, you couldn't break the patches further. So that's why it will take 2.2 seconds for inference. But now like we have a way to break these 224 patches and process just one patch at a time. And you can keep querying it serially and keep rolling out the grid to the memory of your hard disk. So that way you don't have to keep all 224 patches in memory anymore. And when you parallelize it, it becomes 1,000 times faster than a transformer. Now, the key problem is that a person will ask that don't be a smartass. If you are processing one patch at a time, it won't lose semantic awareness, because if the patches don't interact with each other, it's not gonna work, right? But that's not true. So this is the input and this is the grid which comes out of Dino. And this is the thing which comes out of GLOM. Obviously, we couldn't use GLOM, so I call it APM. And if you look at the clustering of the feature map, this is showing the error map between the two. And as we can see, most of it is black and white, with white denoting some error. Most of it is black, which shows that the idea somewhat works. And this is Coco. So it scales up to Coco. And this is Coco Well. So we trained this on Coco Train. So yeah, and that's how like we try to solve the scaling up problem, that just process patch at a time and no need of parallel perception anymore. Yeah. And so in conclusion, basically it seems to us like the philosophy is working and GLOM works, and we had to give it like some, it took a lot of time, but yeah, the reason like we call it a model machine now is because a model machine is something which is very small. Originally, model computation was meant to be an analog device, but a neural network is nothing but an analog computer because it's essentially continuous synaptic patterns. And there is a way to like do everything in O1, and it works very fast. So until at least it works on a digital computer, so we can use it. And till the time like the analog chips come up, we don't know. Yeah, so that's all we had. And yeah, right now I am just like lost right now what to do about this. Yeah.
Rajat, can I ask, so slide 15, is this is something you actually implemented, this APM?
Yeah. So APM is called asynchronous perception machine.
Okay.
And it has the ability to look at any patch and predict the features for it.
Okay, so what are you plotting here? What these little squares?
So this is the last grid of Dino. So if you look at the output of Dino and do TSNE clustering on it, you get this grid. And if you take our network and do TSNE on it, you get this grid. But the only difference is the left is parallel perception, the right is looking at a patch at a time.
I see. So one vector per pixel, and you're doing t-SNE and then showing 3 dimensions of color.
Yes. So everyone does 2 dimensions, but we do 3 dimensions.
Okay.
Because that couldn't find any better way to visualize greater than 3, right? So I don't know how to visualize 4 dimensions.
Got it. And then what's the error map?
The error map is the difference between these grids. So let's say at each pixel, there is a 100-dimensional vector. So you take a 100-dimensional vector here and 100-dimensional vector here, subtract them. You get a bunch of numbers, take an absolute, and then add it up. So that gives you the error at each pixel. And then you plot this error map. So yeah, and you don't need deep learning also because you can directly learn a mapping from input to the last layer. So yeah, so I don't know. I had just a Pascal to work, so I had to, yeah. So this works, but I don't know. So in principle, it seems to work.
What
Yeah.
is your exact architecture? I may have missed that.
So the exact architecture, as I said, like right in peer review, so I can't say everything, but
Okay.
like
But
whatever
it's
I was able to.
Plum based.
Yeah, it is. Right now, we are not doing part hole hierarchies because if you look at Hinton's diagram, it has object level embedding and it has a lowest level embedding. So the lowest level is pixel and the second highest level is object, which is the last layer, but there is nothing in between. And for that, we would need like the supervision of parts, but I was not aware about any data set which contains the parts. So they're still missing there. Yeah. That's all. Thank you so much.
I have a question as well. You mentioned that it took a while to build out the engineering part of the,
Yeah.
curriculum work, and I'm trying to understand. I'm curious about what took up the time exactly.
So what took time is basically trying to get rid of everything because like it required very much thinking and so the reason the capsules never worked is because they relied on routing. And routing is basically you take the columns and you have them route among themselves. And because you route, that's what's causing the memory issue. And we were working on video capsules earlier that never worked. And that's why capsules died in favor of transformers. And in transformers, there is attention. That's also a form of routing. So, but now like we are trying to get rid of routing also. There is
see.
something else which is working there. So yeah, the reason it took us time is because like we had nothing to work on with, right? So we had to like start from bare bones.
Okay, thanks.
Okay.
Any last question for Rajat?
Oh, sorry.
Will you
Yeah.
share the preprint once it's out?
Oh, sorry.
Will you share the paper, the preprint, once it's out?
As I said that right now, like I'm just like entering my 4th year and I can't do much other than like what my advisor says. But like I could just present this and whatever peer review says. After that, yeah, we will try to put everything out.
Sounds good. Right.
you.
Thank you, Richard, for a very colorful presentation. Let's move to our last speaker, Prince. You're here.
Yes, I'm here.
Cool.
Yeah, hello everyone. So my name is Prince, and today on behalf of MLC Nigeria, I'll be presenting an idea that we have that we'd like to work on. So yeah, my group and I will be sharing an idea that we'd like to work on and also like get input from you all. So next screen, please. So you all know that recently AI has advanced to the point that applications that have been released recently, you can see applications in them, or like one way or the other, they've implemented an AI in the applications. And then the performance of these modules usually, yeah, the data sets used to train this module usually contribute to the performance of such modules. Now, in the context of machine learning and natural language processing, I mean, in the context of machine learning, we have computer vision and also natural language processing. And as you know, computer vision deals with classification and detection. And also when it comes to natural language processing, they perform computations with languages, and then we're able to, perform additional tasks or any other tasks with the computations that we get from the languages. Now, the question is, if you add the computer vision and the natural language processing, what do you think is going to happen? Or it's like, yeah, what do you think is going to happen? So that's what we have, like multimodal modules. What multimodal modules are is that it has the ability to combine one or two or more modalities, and then you're able to get capabilities which are more than what the singular modules or what the singular modalities can provide. So a typical example is Lava. We have Lava, and you also have GPT, where you are able to use an image and also text hand in hand. So that's all about multimodal modules. So over here on my left, that's an example of a multimodal module and then how it works. It takes various modalities, perform some computations with it, and then also able to provide us or produce one or more modalities as an output. On the right, these are examples of existing data sets which are multimodal. So we have image text pairs, we also have audio text pairs, as well as images and depth, which sometimes deals with regards sensor outputs and etc. Next slide, please. The question is, can these modules be used to train, and these be used to train modules for downstream tasks in terms of the African context? So there are lots of multimodal datasets out there when it comes to image text pairs, but then can these modules be used for downstream tasks when it comes to the African context? So as usual, you go about performing an initial research. So my group and I performed preliminary research, and then we realized that there's a limited research around this particular area. So the existing data sets that we found was with Avilama. So the Avilama is like a vision language multimodal module, which made use of an image text pairs, and then it has the text, or they made use of a multilingual like data sets, and then the data sets comes in, I think, about 23. It makes use of, I think, no, 12 rather, sorry, it's 12, has 12 African languages in them. So when it comes to like, yeah, the Avilama has the multimodal data sets, although, right, but then it doesn't cover all the languages that, or most of the African languages that's available in the world. And also, one of the limitations over here is like it's the scope and then also its practical utility. So again, like I said, the Avilama consists of around 12 languages only, what does not cover most of the African languages. And then something closer to what we want to do over here is the PALO, which is a polyglot large, I think, module for 5 billion people. Yeah, the PALO data set, or the PALO was trained on the data sets which has images and also associated captions. However, the captions are in, I think, they are around 12 or maybe more, African languages. I mean, not African languages, Western languages. So what we want to do right here is to produce something closer to Palu. So we are proposing something over here, the next slide. And then I'll let one of my co-presenters like continue with what we want to propose. Fatima.
Thank you very much, Prince. Okay, picking up from where Prince stopped. So what are we trying to do? What are we doing differently from Avilama and Palo? So we actually look at the features of Avilama and the Palo model. And the very first one is the diversity part. The Avilama, of course, focused on 12 African languages, but then we have many African languages that they didn't touch. So we are hoping to do that better. And also, when it comes to desk captioning in the sense that we want the captioning to be more informative and to cover a lot of informations when we are doing the image text captioning, which the Avilama didn't cover. There is a sample in the next slide, which I will explain better. And also, when it comes to this, the row size, the Avilama has 1.5 million rows, which is a bit, let's say, averagely okay, but we want to do more than that. And also, when it comes to African languages, like we said, the Avilama covers 12 African languages, but we want to do more than that. Okay, for the Palo is similar to what we're actually proposing. When it comes to diversity, it's really diverse. And also, when it comes to desk captioning, it works better. But then the row size for Palo 2 is not really that great compared to the Avilama. And also, when it comes to the context of African languages, the Palo is missing because the data set it was trained on is not actually African languages. So what we are doing differently is that we want to like broaden the scope. We also want to make it more we want to make it denser, and also we want to increase the role size. We are targeting 3 million hopefully, and also we want to cover as many African languages as possible. We don't have a name for our model yet. We are still at the brainstorming phase. We are still trying to bring our ideas together, but then we've actually figured out what we want to do differently, comparing the existing work that is closer to ours. Okay, just to show us a sample of when we say denser, what do we mean? So please, next slide, please. So we have an image. This image is actually from the Avila dataset. That is the Avilama dataset. So we have this puppy chewing on a sneakers and a white background. And so for the Avilama model, okay, this is the caption for the image in English. Okay, puppy chewing on a sneaker on a white background, and they are trying to translate it to an African language. Of course, this is a Yoruba language. Me as a Yoruba girl, this is not actually explicit to me. It doesn't describe what is actually going on truly in this image. It's just giving like an apparent context. We want to, this is hers. This is what we propose hers to be. Okay, we have a puppy. What type of puppy? We want it to be like more informative. Okay, we have a young Belgian puppy. And also, what's the puppy doing? The puppy is not just chewing, it's energetically. That is like another a keyword there. And also looking at the translation from the English caption to an African language caption, which is the Yoruba language and African language in Nigeria. So like this is actually a more explicit and denser. So that is like one of the examples of what we want to do with our moving to the next slide.
Yeah. Hi, everyone. So, Oluwatosin Olajide, and I'll be like speaking on why I think our research is important and what we aim to. Why we are doing the research is to like more multimodal research to happen in Africa and more people to work on things relating to like current landscape of or current number of people currently working on multimodal AI in Africa are not a lot, and I think that's something that we should change. What is it like go down the line? Why is it important that we have like more people working on like African multimodal AI? If that yeah. So African multimodal AI. Yeah. So next slide, please. Yeah. So why is this work important? Yeah. Okay. So it's to preserve African languages and culture, and I think these images on this thing kind of like show an example of how African, when I say African culture, African things that happen in Africa are being eroded away. The images are actually like supposed to be like so. This is the image on the left are images generated by Stable Diffusion 3, and the images on the right are actual images of what it should be like. So if you type in Stable Diffusion 3 an Ayo masquerade, it brings out this first image of a woman in a mask. While ideally, the image on the right at the top is what an Ayo masquerade should look like. If you type in Atilugu dancers, the image on the left in the middle is what comes out instead of the image on the right and NYC like that. So the last one is NYC, what an NYC copper. And so the thing is when these models are trained, the captions are more of like an African dancer, you get, and they don't specify what type of what the exact description of an African dancer. Africa is quite big and there are like different tribes and cultures, and each of those tribes I imagine have their own like different types of like attires for dance and dancing styles and everything like that. So I think that's one particular thing that our projects kind of like would help to like do down the line is to preserve African languages and culture. Yeah. So yeah, next slide. So along with preserving African languages and culture, I think one other thing our projects like has the potential of like doing down the line is helping bring the benefits of multimodal AI to Africans. And why we think they are like yeah obviously like a lot of Africans know like the Western language and everything, but there are still a sizable number of Africans who are still not comfortable with Western languages and prefer to use their like, mother tongue or their native languages. And what this platform or this creation of data sets can do down the line is help people build better models and everything for better multimodal models for Africans and something that works in their local languages. Yeah. And so what this is just basically we're trying to this is the announcement video of GPT-4o. We're trying to like, just basically bring it into the African context and that's it. Yeah. So I think that's why our work is important. The impact it tends to have is quite immense. So I'm going to like leave it to the last person to round off here.
So I'll be rounding up this presentation by talking about what's next and where do we go from here. This presentation is under the I have an idea segment, and we plan on like fleshing it out into a full research project. So what do we do going forward? First thing is to examine existing multilingual multimodal data sets like the Palo data set, check the number of African languages in them, check how we can improve the data sets so we don't just start from, so we can build on existing work and not start from scratch, and also examine existing multimodal data sets. So what are we looking for in these data sets? Number one, their captions must be dense. The trained models, the reasoning capabilities of the trained models, and the number of African languages included. We don't want a data set that has like very few African languages in it, because our main focus or our main reason for working on this project is African languages. Then what's next after that? We plan project execution and the timeline. These are links to like useful resources, the list of multimodal data sets we've come across so far, the Avi Lama project by the certified group that Prince talked about. And then we also have the Palo paper. Thank you very much for listening. Do we have any questions?
Question from the chat: how many African languages are you guys targeting?
Now, we've not decided yet. There are lots of African languages out there, over 2,000 plus languages. However, the language is not diverse enough, so we are thinking of something more than 200 plus. That's like the baseline over here. But for now, we've not considered yet, because we are planning on including models which will be able to perform like better translations than Google Translate. So we'd have to also consider these modules which will do the translations, like the languages they were trained on, because we cannot basically we cannot use modules which were not trained on a particular language to perform like translations. So all this comes into play when considering the number of languages. But then we are planning on like getting lots of the languages included in our data sets.
I might have missed it in the presentation. I saw on slide 5 you kind of showed paired English and a sentence in another language. Do you plan on this data set mostly being paired data or unpaired sentences?
Sorry, Jason, can you come again?
Here you're showing paired data. So we have a sentence in 2 languages and it's representing the same content. Do you anticipate this data set being mostly paired data, or, for example, unstructured, unpaired, unmatched data?
The data set will be paired, definitely paired. So for example, we have over here an image of a dog. So we'll have like the original translation, which will be in an English caption of the image. So we translate the caption into multiple languages. So those languages will be paired with the images.
Okay, yeah, got it. Any other questions for the team? Just one suggestion for you all. If you could email Roseanne and I afterwards and let us know the names and links for all the presenters, because I think right now we just have a link up on the website, and it'd be great to be able to credit all of you. All right, we should probably wrap up. It's kind of a little bit over time. If people want to continue the conversation on Discord, there's the Research Jam channel, and we'd encourage all the speakers to check out that channel and participate if anyone brings up questions there.
Thank you to all the presenters and everyone that participated in this jam. Thanks for waking up early or staying up late, right? See you at the next event.
See you all.
Bye.
Bye.